Morning everybody. This week we're going to start looking at differentiation. Some classes would have done some of this already. I know my class, we've pretty much finished this topic, I think. So you guys probably haven't got too much to do this week, but you can use it as a bit of revision. Mr. French and Mr. Green's class, I'm not sure how much you've done of this, if anything. And Miss Hughes's class, I think you've done some of this. So what we're going to look at is some more interesting tools which we could use for differentiation. The tools are good for a few reasons. One reason is to make things more efficient, and also secondly, actually just to be able to let us be able to differentiate some things which we wouldn't have been able to differentiate before. Okay, so the first thing I want to start to go at today is differentiating this thing here. Y is equal to 2x plus 5 all cubed. The way I'd like you to do this in the first instance is by expanding these brackets out. You can expand them out by doing double brackets and then timesing it by 2x plus 5 again, or you could use the binomial expansion. I'd recommend using the binomial expansion, it's quicker. And then what I like to do after the expansion is differentiate each term. So have a go at those things. Come back to the video in a moment. I'd have done the expansion, and then you can check again for the differential. So using the binomial expansion, we get 2x cubed plus 3 lots of 2x squared times 5 plus 3 lots of 2x times 5 squared plus 5 cubed. And if we sort that all out, we get 8x cubed plus 60x squared plus 150x plus 125. So can you, if you haven't done so already, can you differentiate that as well? Pause the video and come back to me when you've done it. So differentiating this, you should get 24x squared plus 120x plus 150. Okay, so the next thing, a bit trickier. What I'd like you guys to do is to try and factorize this into a set of repeating brackets. Before you do that, there is a highest common factor of these things. Can you think about what the highest common factor of these things is? And then what's left? Can you stick that into a double bracket, please? Pause the video. So you should find that you can take a 6 out. You're left with 4x squared plus 20x plus 25. And this second bit here goes into a repeated bracket. This is 2x times 2x. This is 5 times 5. And hopefully that would get us the 20x in the middle. 2x times 5 is 10x. 5 times 2x is 10x. Added together will give me 20x. It does work. So what I'd like you to do is go back to the top line here and imagine you hadn't done any of this. Imagine I just gave this to you first thing today and said, do you guys know how to differentiate? Can you differentiate this for me? And remember, you bring down the power and then you reduce the power by 1. So can you think about what your guess would have been and write it down here if we hadn't done any of this? And then can you compare it to what the actual answer is? And just pause the video. Okay, so most people in this situation guess, well, they bring down, most people's guess in this situation is they bring down the power, they bring down the 3, and then reduce this by 1, and that's all they do. Which seems fair because that's what you've known so far from differentiation. You bring the power down. However, that's when you have something like this, 24x squared. So this is the function here is just x, which has been squared and times by 24. So this is really straightforward stuff. You bring down the 3 to get the 24, and then reduce it by 1. In this case, though, it's not just an x which has been hit by the power. There's a whole bigger, more complicated function in here, 2x plus 5. And because that function's in there, we need to be slightly more careful. So you'll see here we've reduced the power by, we've brought the power down and reduced by 1. And you'll see this thing here is 2 times 3, 2x plus 5 squared. In other words, it's really similar, the only difference is that it's been multiplied by 2. So come back and think about what I just mentioned. I said the difference is this something in this more complicated function. My green pen doesn't work. There we go. In this more complicated function here. What can you do with this function to generate this missing 2? Have a think about that. Pause the video. So hopefully what you've thought is if you take what's in the bracket here and you differentiate it, you get 2. If you differentiate this thing in the bracket, 2x differentiated is 2, 5 differentiated is nothing, so we get the 2 out here. So what we seem to have found out is that if you have a more complicated function, such as this one, which is something in a bracket to the power of something else, yes, we drop down the power, yes, we reduce the power by 1, but then afterwards, the more complicated thing in the bracket, we have to differentiate it and times our answer by it. So let's just have a look at an example of that. So here's an example of this. Y equals 5x plus 20 to the power of 4. What I'd like you guys to do is have a quick go at differentiating this, and once you've done that, come back to the video and check how you got on. I'm going to have a go now myself. So if I'm going to differentiate this, I need to pull the power down to the front, which gives me 4. I need to write my bracket out again, 5x plus 20. And then I've got reduce that by 1 to get that as a cubed. But then I need to remember to times through by what's in here. If I times through by what's in here, well, a differential of 5x plus 20 is just 5. So my answer to this one is going to be 20 5x plus 20 cubed. Okay, so let's just show a bit more. Well, actually, let's do a few questions first, and then we'll formally show what the chain rule is. So here's 4 quick questions. Y equals 5x minus 2 to the power of 5. Y equals 2 plus 5x to the power of minus 1. Y equals 1 minus 3x to the power of 7. And y equals 1 minus 2x to the power of minus 3. Can you guys just have a quick go at those 4? Come back to the video when you've done them just to check your answers. So for the first question, you need to bring the power down, reduce the power by 1, and times by 5, which should give you 25 lots of 4x minus 2 to the power of 4. For the second one, you should get minus 1, 2 plus 5x to the power of minus 2. I'll put dy dx there actually. So dy dx minus 1, 2 plus 5x to the minus 2. So I've reduced by minus 2, and I also need to times here by what's the differential of the bracket. The differential of what's inside the bracket is 5. So that's going to be minus 5, 2 plus 5x to the minus 2. This one here, 7, 1 minus 3x, reduce the power. Then I need to times by the differential of what's inside the bracket. That goes to 0, minus 3x differentiates to minus 3. That gives me minus 21. 1 minus 3x to the power of 6. And last but not least, dy dx. And we've got minus 3, 1 minus 2x to the minus 4, and then I differentiate by what's in the bracket, which is going to give me minus 2. And altogether that gives me 6, 1 minus 2x to the minus 4. Okay, so we're just going to have a look at what the chain rule is formally now, We're not going to use this an awful lot today. However, we will use it when we look at other things in the future. For instance, when we look at integration, for instance. And it's really useful if you've got some letters which aren't y and x and you're trying to do some other bits and bobs. It's also useful when we get to parametric equations. So the chain rule formally is this: dy dx is equal to dy du times du dx, and this is where y is equal to some function of u and u is some other function g of x. Okay, that might seem to have totally overcomplicated something which seemed relatively simple a few moments ago. Let's just go through an example of how this works and see that it is exactly what we've just done, dressed up a bit. So let's use this chain rule, this formal chain rule, to differentiate something. So let's say we've got y 3x squared take away 4 to the power of 7. Okay, so if we let u be 3x squared minus 4, then in that case y is equal to u to the power of 7, because this is just u in here. Let's raise to the power of 7. So what's going on here? I've got u, which is some function involving x, in other words this bit, and I've got y is some very simple function of u, in other words this bit. And the chain rule says if I differentiate these two things, if I differentiate this in respect to u, and I differentiate this in respect to x, and then times them together, I'll get dy dx. So let's just try that and see if it works. So dy du is going to be 7u to the 6. Drop the power, reduce the power. And du dx is going to be, if I bring the power down, I'm going to get 6x, and then that goes to nothing. If I now times these things together, I'm going to get what dy dx is, hopefully. So I've got this times that, 7u to the 6 times by 6x. Well, I've got dy dx here, so I kind of just want x's on this side, and I've got a u. But I know what u is. U is 3x squared minus 4, so I can sub that back in. So I can sub 3x squared minus 4 back in for the u. And so if I just tidy that up a bit, I get 42x squared. 3x squared minus 4 to the power of 6. Let's just compare this to what we have done further up the page. I started with this. I dropped the power to the front there. I reduced the power by 1 here. And then I times by the differential of what's inside here, which is just 6x there, and then tidied it up. So what we did earlier was probably a very simplified version and a particular version of the chain rule. This shows you that the chain rule works for this. However, it's really important that you remember this process. You remember this process, and if you get something really difficult to differentiate, if you can write it in this sort of form, then you can have a good go at differentiating it. You guys know what the differential of e to the kx is, for instance. And hopefully when you learnt about that, your teacher would have said that we're going to prove that this is actually true when we learn the chain rule. If you want to go away and give that a crack now, you can. We will give it a go when we come back to differentiation in a few weeks' time. Anyway, so that is the chain rule. What I'd like you guys to do today is do not an awful lot else apart from practice using the chain rule over and over and over again. I'm going to set you 2 sets of exercise sheets to do, and what I'd like you to do is the following. I'd like you from the level 1 sheets that's not the modulus of V, by the way, that's level 1. From the level 1 sheets, I'd like you to do question 2, question 4, and question 7. And from the level 2 sheets, I would like you to do question 1, question 3, and question 4. Okay, if you've got any issues with that, give me an email. I should be on my computer most of today, so I should be able to write back to you pretty sharpish. And I'll see you tomorrow, where we will look at doing something called the product rule. It's really important that you try and get this work done before you do the product rule work, because you're just going to have to be able to use the chain rule. Without any of this, you just need to know how to do it straight away. Okay, have a lovely day, and I'll speak to you guys again tomorrow. Bye-bye.